Welcome back, AP Pre-Calc. It's Miss Adams from Flamingo Math. We're going to finish up day 2 here with a little more in-depth matrix multiplication. First, look at these 4 important concepts. Just because AB is multiplied together doesn't mean that BA is the same value. And if AB equals AC, it's not necessary that B and C are equal. And if you get a product of 2 matrices and the result is 0, you cannot assume that one of those matrices was 0. And how to use a graphing utility to perform matrix operations will be in this lesson as well. So first, let's show that the commutative property doesn't hold by demonstrating AB is not the same as B times A. I'm going to use my highlighter here to show you that when I multiply the first row in the first column, we're going to get 0 times 1 and -1 times 2. That's going to be -2. And then first row, second column, 0 times 5 and -1 times 3 gives us -3. Then in the second column and second row, 1 times 1 and 2 times 2 is 4 plus 1. We get a 5 there. And then second row, second column, 1 times 5 plus 2 times 3 is 5 plus 6. That's 11. So AB is -2, -3, 5, and 11. Then B times A is going to give us, get my highlighter out again, row 1 times column 1. We have 1 times 0, 5 times 1, that's a 5. 1 times -1, and 5 times 2, that's 10 minus 1, that's a 9. Then we have row 2, column 1, row 2, column 1, 2 times 0 and 3 times 1, that gives us a 3. And then row 2, column 2, 2 times -1, that's -2, plus 6, -2 plus 6 is 4. So we have proven that AB is not the same as B times A. Example 8, we've got A, B, and C, and we want to show that AB and AC are the same, but B and C are not equal to each other. You might want to give this a try on your own. And hopefully, if your work looks like my work, the product of A times B is 1, -7, -2, 14. And then the product of A times C ended up being identical to that. But matrix B, which is right here, is not the same as matrix C right here. But we did get the same 2 results in that matrix product. For example 9, we're going to construct a 2 by 2 matrix so that AB is a 0 matrix, and we're going to use 2 different non-zero columns for B. So let's set that up like a little puzzle here. We've got -6 and -2, 3 and 1, and we want to multiply that by 4 numbers, A, B, C, and D. And our result is going to be 0. So we've got what, -6A and 3C in that first column. We have -2A and 1C in the second column, and those have to be 0. And then for the that's 2 of them. And then the second element says -6. So I've got row 1, column 2. So -6 times B and 3 times D has to be 0. And then -2 times B and 1D has to be 0. So this set relates A and C, and this set relates B and D. And if you solve those, you're going to find that A is 2, B is 3, C is 4, and D is 6. And we can check that -6, 3, -2, 1 times 2, 3, 4, 6. They're two different non-zero columns that we're going to get 0, 0, 0, and 0. And you can kind of see that. This is -12, this is +12. This is -4, this is +4. This is -18, +18, and -6, +6. How about that? Example 10, let's try solving a matrix equation here. We want 4x to equal c. So 4 times x, let's see, x would be 1/4 of c, right? So we could find x by doing matrix multiplication on the elements in matrix C. 1/4 of 12 is 3, 1/4 of 0 is still 0, 1/4 of -4 is -1, and 1/4 of 8 is 2. So we solved that matrix equation. In part B, a little more complicated, if we isolate x, x is 2a minus 3b. So let's solve that. 2a minus 3b. We don't need that. X is 2 times a, 5, 1, 3, 6, 0, -2, minus 3 times b, 0, 2, 4, -3, 1, and 8. So our first product is 10, 2, 6, 12, 0, -4. And let's turn that into addition, since we're going to think about -3 times 0 is 0. Wait, did we do this? 0, 2, 4, yes. -3 times 0 is 0. -3 times -3 is 9. -3 times 2, -3 times 1, -12, -24. So we want to add those together. 10 and 0 is 10. 2 and -6 is -4. 6 minus 12. 12 and 9 is 21. -3, and then -28. So our X matrix would have those elements. Now, in the next example, you need either a TI Inspire CX or a TI 84 Plus. So I have the screenshots here to walk you through what we're going to do. Depending on which calculator you have, you can follow along with these directions. I'm going to talk about the TI 84 Plus. So if I want to create a matrix, I'm trying to create this matrix. You press the second button, the inverse, x to the -1 power, and then hit edit, and it's going to pop this up, and I want to make a 3 by 3 matrix, 3 row, 3 column. And I'm also going to make the second matrix B, 3 row, 3 column. Then we need to set the rows and the columns. That's what we did there. Next, you want to enter the elements for matrix A one at a time, and then go back and enter the elements for matrix B. So I'm just going to show you matrix A. Here's how you do that. You press second, the inverse, and 1, and then second, the inverse, and 2. When you press enter, you can multiply the matrices together. So you've entered in the elements like this and this, and then when you do these steps here, step 5, it'll multiply matrix A times matrix B. For example 12, you can see we're being asked to multiply A times B using your calculator. If you follow the steps in the notes, when I multiplied A times B together, this was my product. Then I want to subtract matrix C, so matrix C is over here. And when we do those operations, I'm just doing it by hand here, I get -5, 17, -52, and then 37, 20, and 23, -5, 1, and -26. So this is my operation AB minus C. When you square a matrix, you can do the same thing with your calculator. You just create matrix C and enter all those elements in there. And then once you have that, you go back to your calculator, choose matrix C and hit a square, and it's going to square it. So it's multiplying C times C. And those final elements are 27, -8 in the first row, 24, 7, -2 in the second row, and 2, -5, 30 in the third row if I did all my calculations correctly. And finally, for example 13, it's another application question. We have the lacrosse team at Olympia High School. They have a list of equipment for the athletic director to purchase for them. And each stick costs $55. The helmets cost $175. And the protective gear cost $125. We want to use matrices for cost and equipment to find the total cost equipment for each team. So we want to set up S, H, and G. So the stick, the helmet, the stick, the helmet, and the protective gear cost $55, $175, and $125. That's my first matrix. And then the equipment for men is 20, 14, 15, and for women it's 18, 15, 14. So this is, the product is S and H and G when we multiply, and men on the top and would be the first column, and women would be the second column. And I believe if we multiply those correctly, let's get a highlighter here, these 3 elements times the men, and then those same 3 elements times the women. And my results were 54.25 for men and 53.65 for women. So the total cost, if we add those together, for the athletic director, the total cost would be $10,790, and that would break down with 54.25 for the men's team, and the remainder, 53.65, would be for the women's team. I hope you've enjoyed this lesson. We'll talk about matrices and their inverses in the next lesson.